This is a Cloud RF tutorial for modeling uplink. Uplink is a popular problem in modeling a repeater where you have a tall and powerful repeater talking to a low power portable radio. We want to model both directions of the link in one API call with one color schema, which we'll do now. To do this, you need to find out what your power levels are in decibels, or decibel milliwatts in our case. Type in your power in watts into the RF power box and note down the ERP as dBm. So 37 dBm is 5 watts. The next power level we want to model is a high power mobile radio at 25 watts, which is 44 dBm. And finally, a high power repeater might be 50 watts, and this would be 47 dBm. What we're interested in here is the difference between these different power levels, because that's what we need to generate a color key. Now, to generate a color key, we're going to use the custom color key tool down here. That's the little palette which takes you here to the color key generator. We're going to be using signal to noise ratio, which means we need to select dB first of all from the list, and then we need to use the values that we identified earlier to make our color key. I need to give this a name, so the first one I'm going to do is going to be the 25 watt to the 50 watt. So the 50 watt is the repeater, the 25 watt is the mobile, and the top level here is going to be the uplink. Now, if you remember, for the 25 watt versus the 50 watt difference, well, those two numbers, the larger number is double the first number, and in decibels that's plus 3 dB. So the step size is going to be 3 dB, and the top number is going to be 8. And the reason it's going to be 8 is because our threshold for this system is 5. So 5 dB SNR. 5 plus 3, which is the difference between the two numbers, gives us 8. We don't need a rainbow schema with lots of bands, we just need 2 bands. So let's use the arrow key here to reduce the numbers. It's important at this stage that you pick consistent colors. So when you're comparing different types, you're using the same color schema. Whatever you choose, in our case we're going to choose green for the uplink, which is the larger of the numbers, and leave it as blue for the downlink, which is the lower number. Save your color schema, and now we have a color schema here. Here's two I made earlier, 25 watts up and down, and 5 watts up and down. Notice the downlink is the same, so the downlink threshold hasn't changed. What's changed is our uplink threshold. For the lower power radio, that threshold is higher. We need to see more signal in order to have an effective link with the low power radio. Let's go and use those templates now. This is a 2 meter VHF repeater, it's very tall. We're going to go and select first of all the 5 watt up and down template. I should add that for the settings we've got SNR as the measured units, and the sensitivity matches the color key. That's important, otherwise it will get black. So first of all, let's run this one. 60 kilometer radius, 30 meter resolution, and the reliability was conservative there at 99%. And as you can see, it's fairly variable coverage. In some places the downlink is effective, in other places there's no communications at all, and if you want to investigate why, you can just click the path tool here and click into the void and see why. And I expect to see some obstacles here, -2 dB, so there's multiple hills and wood blocks. So wood blocks are attenuating, we are using temperate for the profile. Finally, to compare, we keep the repeater in the same location, we switch to the other color schema that was made, and we can compare. And this is why we had to keep the colors the same earlier. And now this is a more powerful mobile radio. The repeater coverage hasn't changed. Where it's blue is still blue. What's changed now is that we can now talk back from places where we could not talk before. So if I zoom in here, we couldn't talk in before, but now with a mobile radio with 25 watts power, we can talk back into that repeater, and it's much more balanced. And by balanced, we mean the downlink is much closer to the uplink compared with this one here.